Welcome back to our series on applied regression analysis. I'm Mark Ledbetter, and this is lecture video 5, and we're doing the third part and final part of the basic probability. In this lecture, we're going to talk about conditional probability and the multiplication rule for probability. So again, we're just trying to get an idea of basic probability, not the in-depth theory like we would in probability theory course. So this is just a cursory introduction to probability. All right, so let's define conditional probability. A and B are two events in the sample space S. Then the conditional probability of event A occurring, given that event B occurred, that is calculated this way. And it's a probability function, but now inside the parentheses we have A given B. Now I want to point out what we're trying to find the probability of is A. A is what we're interested in. But we're limiting ourselves to the case where B is true or has occurred. Now, many students, including myself, when I first learned this, would not get the fact that B has occurred or did occur or will occur. We don't care about anything that happens if B did not occur. So don't overthink this. Don't make it something that it's not. We are absolutely saying that B occurs or occurred. B is true, however you want to think about it. Okay, so B has to be true or has to have occurred, that event. And then we take the probability of A and B, the intersection, divided by the probability of the event that has occurred, which is B. So the pattern here is that both of them occur in the top, A and B. And then the one that is given or has occurred or fixed as having occurred is B, and that's on the bottom in this case. And remember that the probability of B has to be greater than 0. It can't be negative. No probability can be negative, but it could be equal to 0. But this doesn't work if the probability of B is 0, which makes sense because if the probability that B is 0, then there's no conditional probability of A given B because B is not going to happen. Now, notice that we cannot reverse the order here without changing the probability. So the probability that B occurs, given that A has occurred, is different than the probability of A, given that B has occurred. What's different is the denominator. The numerator stays the same, so the pattern remains B and A, but B and A is the same as A and B. It doesn't matter which one you write first, right? You can write either one first. But what does matter is that now that A is to the right of the bar, so A is the one that's fixed or given, the probability of A is the one that's on the bottom. And again, probability of A has to be greater than 0. And since students want to forget this when it's difficult not to forget this, I want to be very clear that the probability of A given B is not, in general, the same as the probability of B given A. They're only the same if the probability of A is equal to the probability of B. That's the only time they're equal, but that's a special case. So don't fool yourself by trying this with flipping a coin, because then you'll get the same result and you'll say, oh, they are equal, but they're not.
In this problem, we're going to look at 20 tulip bulbs, and we're given this table here so we can see what's going on with them, and we're asked to select one bulb at random and figure out these probabilities. So I'm looking for the probability of early. So here's early, and the total here is 8, and the total bulbs in my sample space would be 20. So there's going to be 8 out of 20. That is my answer. Please do not reduce the fractions unless I ask you to. Okay, and then the probability of R is here. There are 13 of those, so 13 out of 20. And then an intersection is very easy with a table. We don't have to use the multiplication rule, which we're going to learn next. But we're looking for both red and early. Here's red, here's early, and you see where they intersect. So it's simply 5 over 20. Now we want to find a conditional probability, and it says what's the probability that a bulb is red given that it blooms early? So we need to write out the symbol for this. We know how to write the equation. So red given early. And then we can write the equation, R and E over the probability of E. And we have these up above, 5 over 20. And then E is 8 over 20. If you need to invert and multiply, you can, but I'll show you that what happens here is that the denominators cancel. They're the same, and when you see that, you can just cancel them. You don't need to do the invert and multiply if you see that they're both the same. You can just cancel them. And that is my answer. Now this is using the formula. I can also use the table to find this directly. And here we're going to change our perspective, and I'm going to clear this up a little bit. And so what we do here is we say we're only interested when E is true. So here's E. So now this becomes my new sample space. I don't care about anything else. I only care about if E is true. So now, given that E is true, what's the probability that I'm going to get a red? That's going to be 5 over 8. So please take a moment to think about that, and you see that you get exactly the same answer. So if you have a table, you can do this. If you don't have all the information, then you can't. So here's a case where you have to use the formula. So here I want to note that the 0.5 is only this portion, and the 0.1 is only this portion, and then the 0.2 is the portion in between. So if I ask for the probability of A, I have to add 0.5 plus 0.2 equals 0.7, and the probability of B is 0.2 plus 0.1 equals 0.3. The probability of A and B is simply given to us in this case. Now, the probability of A given B is the probability of A and B divided by the probability of B. I've given myself a little more room down here to do this and the picture, so why don't we do it here? So I've got the probability of A and B divided by the probability of B. Probability of A and B was 0.2. The probability of B is 0.3. Please don't leave it like this. I don't like the decimal in a fraction. That's not proper. So we'll do the division and 2/3, and you can leave it that way. And then the probability of B given A is still the probability of A and B, but divided by the probability of A. So it's still 0.2, but now divided by 0.7, which gives me 2/7. All right.
Now let's talk about the multiplication rule. So we start off with the conditional probability formula that I've just given you. The probability of A given B is equal to the probability of A and B over the probability of B. Remember the pattern, that whatever is given to the right of the bar, that probability goes on the bottom. Now what I'm going to do is I'm going to multiply both sides by the probability of B so that I can rewrite this and get the probability of A and B by itself. And so that's going to be the probability of B times the probability of A given B. And this is only true again when the probability of B is greater than 0. Why? Because we started with this formula and you can't divide by 0. So that condition follows through for the multiplication rule. Now let's look at the other conditional probability, the probability of B given A. Again, probability of A and B over the probability of A now, because A is given. Multiplying both sides by the probability of A gives us the solution for the intersection of A and B, and that's the probability of A times the probability of B given A. Again, in this case, probability of A has to be greater than 0. And so in this, on your formula sheet, this is what you want to write. The probability of A and B is either the probability of B times the probability of A given B, if probability of B is greater than 0, or it's the probability of A times the probability of B given A when the probability of A is greater than 0.
So here's another example. We're given that the probability of an applicant being admitted to college, a certain college, is point A. So I'm point 8. So I'm going to say A equals admitted. So the probability of A is equal to 0.8. So you'll notice that I'm writing down stuff as I read the problem. And then the probability for a student in the college to live on campus is 0.6. So now, this is tricky. They're already a student. So the probability, let's say B, sorry about the zoom there, it happens automatically sometimes, is live on campus. Now, they're not going to live on campus unless they're a student. That means they've already been admitted. So the probability that's given to us is the probability of B given A. That is 0.6. It's not the probability of just B. All right. We've been given the probability that they live on campus given that they're a student. And it doesn't say given anywhere in there. So this is kind of a tricky problem here as far as wording. You have to really think it through to be able to get this. And they've asked what's the probability that an applicant will be admitted to the college. I've given you a keyword and be assigned to a dormitory housing. So what I'm doing here is I've got the probability of B given A is equal to the probability of A and B over the probability of A, and I'm looking for this quantity. So I'm going to multiply both sides by the probability of A. Since that's not 0, this is defined. So I've got the probability of A times, I'm going to rewrite this. I'm going to write it as the probability of A and B is equal to the probability of A times the probability of B given A. So this is called our multiplication rule. And when you have a table, you don't have to use it. Okay, so now I can plug in. I've got 0.8 times 0.6 equals 0.48. So that is the probability that they are both admitted and assigned a dormitory or living on campus. Now, don't forget to scan these lecture notes that you're taking while you're watching these videos. They're due by midnight on the date given on the course calendar, so make sure you scan them into the Google Drive by that date. And please be neat with your notes. I hope you've been neat because they're for you. I grade them, but they're really for you to use for the homework and the test. And then make sure that if these formulas for conditional probability and the multiplication rule, and I'll go back and write one more, the probability of A and B can also be written as the probability of B times the probability of A given B. So you may want both of these rules in there. Two different ways, depending on what you've been given. If you have questions, please come to my virtual office hours. If those times don't work for you, please email me. And if you want, we can set up a meeting that's not during those virtual office hours. We'll see you next time. Until then, think probability.